This is a Halicrafters model S118 receiver, and a friend of mine sent this to me from the East Coast. Paul, thank you. And we're just going to take a quick video of this, maybe do an analysis and understand what the status of it is. I don't know a lot about these. I do know that Halicrafters is a good name. It was a big name, and I think this was produced somewhere between 62 and 65. We'll see if we can figure out kind of a better date on that. But I'm guessing that this is probably a pretty good receiver. I have to take a look and see. I know it's at least partially tube, maybe full tube. The IF, maybe solid state. I haven't looked at the schematic for it yet. I do have it, so we'll take a look. But yeah, this does 5 different bands. So it does long wave, broadcast, and then 3 shortwave bands. So we've got what, 1.7 to 4.6, 5 to 14, and 15 to 30. Nothing really on shortwave anymore. Maybe we can find out what time it is from shortwave. That's about it. So we would mainly, I think long wave, we might be able to pick up some stuff there, and certainly broadcast. We'll be able to listen to standard broadcast, and there's a couple of stations there, so be interesting. I'm curious if the tubes on this thing are going to be completely destroyed because it's got a standby mode. This thing hasn't worked, from my understanding. It hasn't been touched in years and years. Obviously, controls are frozen on it, and certainly we'll clean those. So let's just get into this thing. Did notice earlier that the power cord's been cut off. That's fine. We got power cords here. We can replace that. Probably just open it right up and take a look at the chassis. This is from an era where it'll have some wax capacitors in it, maybe orange drop type capacitors, or epoxy type capacitors. Certainly the electrolytics from this era were pretty good. Arguably need to be replaced, but we'll take a look and see. We'll bring it up on a dim bulb just to try and not completely destroy it. It is a transformer set. We don't want to ruin that. Not that it will, but I believe this is solid state rectification at least, so it's going to hit immediately. It's not like we're waiting for the rectifier to warm up. So let's just we'll power it up and see if it works, and if not, we can do some troubleshooting on it and see what's going on. I happen to have some knobs laying around. This knob was missing. This is the fine tuning band spread, and this is the coarse tuning. We have volume control, of course, our different band selections, and sensitivity. The sensitivity can be dialed up and down on this. I think for rural areas you can turn it up. Certainly here in the city we might not need so much sensitivity. So it's a pretty basic looking receiver. Taking a quick peek, so it's got an AM bar antenna there. You can also put an external antenna on it. Auxiliary power, I'm sure battery maybe. It's got a jumper plug in it right now. 40 watts. It's actually kind of low. I guess maybe not for this era, for the miniature tubes. So you have your IF cans. There's your IF. So it looks like it is tube IF. And there's a Mallory. I spot that right there. So that's probably good. We'll find out. And I think I saw a tube chart on the bottom of this too. I think it's got a 6AQ5 in it. And here's all your tuning slugs down there for the various different bands. And it looks like it's got capacitor trimmers too, maybe. That's what all those little holes are next to them. So, like I said, I don't know a lot about this thing. I don't know a lot about these in general. I work on a lot of vintage electronics, but I never worked on a Halicrafters before. Of course, there's your power transformer. Hopefully that's good. If that's bad, the thing just goes in the trash. So how do we get the chassis out of this thing? The bottom. Probably take the bottom screws out of it. I'm hoping that I can just slide the chassis out of here. Should be able to pretty easily. I'm sure this is serviceable from this era. We'll just slide the chassis out of it and take a look at the bottom side. This is kind of what I was hoping, and I guess I would expect it from something like this. The whole chassis slides out. You don't have to take the faceplate off. You don't have to take the knobs off, you know, like a cheaper AA5 or something like that. It literally just slides out of the case, so that's nice. Let's see what's behind door number 3. Ah, this is better than I expected. Those might be good. They might be bad. But we have a whole bunch of silver mica and epoxy and disc capacitors. So this thing will work. Unless there's something majorly wrong with it. All these tuning slugs, they've all got silver mica plus minus 2%. I'm seeing there. So the cans, I'm wondering about the IF cans. These IF cans, they could have silver mica issues where the silver mica becomes conductive, it absorbs moisture over time, and that'll show up in the first 10 minutes if it works, if they have it. But it's nice to see there's only, 3 cans? I got one there, and one there. And these ones do get silver mica disease, so that'll be evident by crackling noises, but I'm not sure what all the trimmer caps are for yet. I see ceramic capacitor across that one right there. Ceramic tube ones. I think we'll just preemptively clean all these controls because they're going to need it anyway, so I'll spritz something in there. Here's your fine tuning. Actually, it doesn't look like fine tuning. Band spread. I thought I had read in the manual this was band spread, but what's that controlling? I don't see anything on the back here. That looks to me like it's just moving a tuning dial. So I don't know. We'll have to figure that out. These are suspects. Sometimes these dry electrolytics are good. Sometimes they're not. Let's see. Here's the power cord here. We'll put something in here in the meantime. We'll put a cheater cord on here. See if we can get it working with that, and then we'll replace it if we're in good shape. Let's lube these controls up and find a power cord for this thing, and we'll dim bulb it and see what happens. So, I wasn't looking at the tuning cap. So this is the fine tuning band spread. So it basically, it looks like it interrupts 2 of the tuning plates, and that's how it fine tunes. And then you've got obviously your main tune here. It's moving smoothly, so I'm not going to lube it right away. I did lube the controls up, so that all works. I get the feeling this thing's going to work. It's really not in all that bad a shape. I did lube up the controls. I still need to lube up these guys. I forgot about those. But let's we'll put a cheater cord on here, like I said, and I'm going to start off with a 25-watt light bulb and just let it kind of, soak in for a little bit. All right, we got the switches lubed up. So this is for standby and receive. We're leaving receive. We don't want it in standby right away. I guess we could. That would just keep the filaments warm. But we're doing a light bulb, so who cares? Off, fine tuning, volumes off. Okay. And 25-watt light bulb. Let's see. Yep, and I would expect that to be full brightness because it's only 25 watts, but let's let it sit for a little bit and we'll see what happens. And we could probably go up to, I think I probably got a 60-watt light bulb sitting around here, and it should work with a 60-watt light bulb. The 25-watt is getting dimmer, so that's good. So we'll let the capacitors reform with that and see if it is getting dimmer. So let's let it sit for like 10 or 15 minutes. So it's been sitting for a few minutes, and the 25 watts getting pretty dim. I've only got a 100-watt bulb sitting around. For some reason I can't find my 60, so we'll just hit it with 100, right? It's not getting bright, so that's good. And this has got solid state rectification in it, so it's not like we gotta wait for the rectifier to get warm. So, unless that light bulb's no good. Which it might not be. I feel some heat. I do feel some heat in it, so there we go. We got some audio. That kind of makes for a boring video, kind of as anticipated.
An NHL record 7 goals in a 10-6 victory over the Toronto St. Patrick's. This week in 1950, high school pitcher Paul
Speaker's bad.
Pirates for a record $100,000.
Cone has come loose. So we can glue that back down, though. I've got some PVC E-glue that works great for gluing this stuff back together. So let's see. That's that sports station. This 1070 should be right around here somewhere.
Speaking with a couple, the wife here when she was 9 months old. She's
I guess that's probably KNX.
3 years old, and he's now 34. So they lived here their whole lives, and their
That's sensitivity.
husband, especially,
You turn the sensitivity, that kills it.
he was a DACA recipient. The program kind of
Fine tuning.
not been able to get a green card or citizenship. So they're out here today, and that's the story, as I understand, with a lot of the other young.
Let's see, where's dirt in the tuning condenser. This speaker kind of sucks for 6AQ5. The speaker is kind of a wimpy speaker. I guess it wasn't really meant for audio quality. It's a multi-band receiver. I don't know, it doesn't seem very sensitive. I honestly have no idea what BFO and ANL is. No clue. So I'm dumb when it comes to some of this stuff. I'll probably, I'll read whatever the abbreviation means in the manual and I'll go, duh, but yeah, I'm not too in tune to it. The sensitivity is kind of crap, though. There should be 1260 should be right around here, and I'm just not getting anything. And I would expect this thing to perform really well. Of course, it gets all the Spanish stations loud and clear. Damn, that's annoying. We gotta glue that back down. See, the cone is lifted. We have to put some glue under there. Oh, let's see, that's long wave. I don't expect to find much there. I think that might need a different antenna. Let's see, that's short wave. Let's go to this band. There should be, we go all the way here to 15 megahertz. see. Sounds dead over there. Did the oscillator die? Does it not work down there? I don't hear anything. That sounds dead. Back to broadcast. This thing sounds dead. What happened? The oscillator quit? What's going on here? There. I think that there's some dirt in the tuning cap, and that's killing the oscillator. I'm going to have to clean that. Well, there's our 1260 Go Country Gold station. And I had to move the bar antenna to get it to work. It was a little too close to the LED lights in here, which screw with everything. I think I can put a power cord on this. Not really much of a video here, you know. It works. I'll have to read the manual and see. This seems to kill the sensitivity a little bit. This is a sensitivity control. I'm not sure what BFO is. I'm just not too familiar. We could do an alignment on it, but I mean, if it's picking up 1260 inside here, it's doing pretty good. So throw a power cord on it, I guess. Oh, and I did go up to full voltage here too. I went around the light bulb, although a 100-watt light bulb wasn't really going to phase this much. So I was right. There is a problem here. Let's see if you can hear it. This plate's making contact somewhere. And we just fix that simply by bending the plate. Let's see, that should fix it. It's still hitting somewhere. There's dirt in there. See, it's killing the oscillator. Maybe I need to blow this tuning capacitor out, because let's get it all the way open. And maybe I just need to tweak that plate over. Just tweak this plate. Yeah, let's see if that fixes it. Yep, that's way better. There we go. You can't have those plates touch. The second that happens, especially if it's on the oscillator capacitor, which that one obviously is. So that explains why I wasn't getting anything down here on broadcast, see? Now we are. Let's see. That still sounds... we got something there. I remember BFO from when I got my license, and I can't remember what it stands for, but... Let's see, what is it? Is it 10? Is it 10? 9? I can't remember where the time is. They use it for the atomic clocks. Sound like an idiot, because I am. And you know, when you're on shortwave, it's really, you got to be selective, not spinning the band like I am. It's 20 meters. If we go up to shortwave, if we go up to shortwave 5 here, I think we get into the CB bands. I think 27 megahertz. There actually might be something up there. Let's see. That's dirty tuning cap. We need to clean that. I bet I need to put a clip lead on there because it doesn't use the, I'm being an idiot. It doesn't use the it doesn't use the bar antenna. There we go. Well, that woke it up. Just turn off my soldering iron too, because that thing's noisy. CB, I'm not going to pick up much. This thing works pretty good, actually. Got the new power cord put on it, by the way. I put a grommet in the back, and because I had to use a 3-prong, so somebody will think it's actually grounded. That's all I've really done to it. It's, you know, I've tweaked that plate like you saw. I greased up the gear here. I might put a little drop of oil in the tuning cap. That's about it. I'm not going to recap it or anything, you know. This cap is getting a little warm, but I think it'll be all right. And if it's not, well, it'll sploot out, and that'll be that. We'll replace it, but I think it's fine. We'll listen to it here in the garage for a little bit. I got some work on the car to do. This thing works very well. And it's funny, you know, I feel like a complete idiot. It's probably because I am. But, you know, BFO is beat frequency oscillator, so that's for CW. And A&L, I wasn't as familiar with this. This is automatic noise limiter, so, which I guess it probably puts a capacitor in circuit or something and suppress the noise. So you can turn the sensitivity down. It really just kind of acts like a volume control, but I suppose if you're in an area with a lot of noise and there's a strong signal, you might dial that down. Like KNX, for example. I bet.
No purchase necessary. Restrictions apply.
That's KNX, and it's almost overloading. See, I can dial the sensitivity way down. And that'll cut the noise down because the sensitivity is lower, and you got a 50,000 watt transmitter that's like, you know, 10 miles away. Yeah, this thing's neat. It's a great receiver. It's got really good sensitivity. It definitely picks up. You know, I use 1260 as a gauge just because it's not a very strong transmitter. I forget how many watts it is. It's, you know, 5,000 by day or something like that, or 7,000 by day. And it's, you know, I'm down beneath, you know, the Santa Monica Mountains, so it gets blocked. The transmitter's up in Mission Hills, which is kind of North Valley area, so it doesn't cut through really well. And especially in the area that I'm in, there's a lot of noisy stuff, electrically noisy things. So this thing seems to receive quite well. Got good sensitivity. I mean, that's basically coming in full quieting. There is noise in here from different switching power supplies, those make noise for the LED lights and stuff. So it works good. It's too bad there's not really anything else on any other frequencies. Anything on shortwave broadcast is about the only thing that we're going to get. Anyways, that's just a Halicrafters S118. A friend of mine sent me. Didn't really need anything. We just put a new power cord on it, new line cord, and cleaned it up. The electrolytic on this did get warm once, which is to be expected, and it's just ice cold now. I think it reformed well. I'm not going to do anything with it. I'm not going to recap this. It works nice the way it is for the amount that it's going to get used. It doesn't need all that, and it doesn't have. It's got ceramic disc capacitors in it. Those don't usually go bad, so pretty rock solid unit. Little Pure Prairie League.
Santa Clarita, thanks for listening to Go Country Gold.
It's a good radio. Alright, well, this thing died, and I actually didn't publish this video for months. And I wasn't anticipating this, so I guess I'll just make this part of it. 15 watts. Yeah, something went open. Something definitely went open. Maybe we lost a tube. Something's not conducting. It's probably the copious amounts of shit that are stacked on top of it and the heat in here. And it was on for a long time the other day, so let's get into it. That's warm. That's getting warm. This is ice cold, and this is the audio output tube, I think. This doesn't use a filament string, I guess. This is 6AQ5, and it's cold. So do we not have B+? That should be getting very, 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 very warm. So either the tube went, nothing. Okay, let's get the meter on the bottom of this tube socket, see what's going on. It's the bottom of the 6AQ5. And we should have B+ off of one of these resistors. Nothing. Nothing. Like this whole thing is dead. Okay, so we have B+. It's right here. I just wasn't quite seeing the pin. 187 volts. So we got B+ there. Do we have filament voltage, though? I'm starting to think that we don't have filament voltage here. Three and 6. We have an open filament in a 6AQ5. It's a bad 6AQ5. Okay, so I was off in my pin count. It's 3 and 4, so the tube is good as far as the filament goes. It's not open now. I'm checking because it's 3 and 4, it's these two resistors that feed it. I'm checking the voltage pre-resistor, and I've got 13.6 volts. So I've got 13.6 volts on this side over here of this resistor. So 13.6, 13.6. If I move to this side of this resistor, I got nothing, and I got nothing. So is this resistor open? Let's just do this. Let's just do this live here. All right. It's showing 9 ohms. Of course, that could be going through somewhere. So working without a schematic, it makes it a little bit fun. But I understand now these two tubes are in series because there's 13 volts here. This resistor is in between the two tubes, and we have a 13.6 volt drop between the two, which means that this resistor is bad. This is open. We have a total voltage drop between those two points, and it should not be. I believe there should be a 6 volt drop between these two. Well, I don't know if it's going to be exactly 6 volts because you have the tube filament too. Although that's, yeah, I don't know. This is where my brain doesn't think fast enough to do this on the fly. But at any rate, there shouldn't be a 13 volt drop because they're taking the 13 and dividing it. So this resistor's bad. So that should be a 5.6 watt or 5.6 ohm resistor, 1 watt. Sure. Let's see what happens. Hey, there we go. Is it glowing yet? Is it smoking? Hey, how about that? Get the noisy stuff out of here. Where's KNX? Right in here somewhere. Something's very noisy. Ah, there we go. Switch mode power supplies. They'll screw you up badly. Okay, either way, we know this is pulling 30 watts. Let's disconnect this. It's going to fall rapidly. It's going away. As the tube gets cold, we lose it. So, and we let the tube warm back up through our new resistor there. I'll get an appropriate resistor for this. That's just as a test. So, yep, we got an open resistor right here. So this is like a 5 watt resistor. It's measuring 5.9. That's about as close as I'm going to have. So it's a little bit high, but a little bit high is okay. That's actually better. 5.6, 5.9, it'll work. And yeah, that little 1/4 watt resistor was smoking by the time that I turned it off. Ridiculously oversized resistor has been installed. Let's plug it in and see what happens. I don't really have any 1 watt resistors floating around for whatever reason. These little metal film Chinese things that I use for making quick repairs, they are supposed to be rated for 5 watts, but not a chance. So that's supposed to be a 1 watt resistor in there. That sucker was hot. There's the classical station. Just wanted to get that down away from noisy power stuff. So pretty simple repair. Open resistor. It's supposed to be 5.6 ohms, and let's see if we can do this live here. That's a motor, a compressor turning on. That's why we're getting a bunch of noise. 340 ohms. So, yep. Carbon resistor went open. That's kind of what I expected to find across the tube. So it's just a hair low, which is fine. It's actually a good thing. 5.7 volts out of 6. That makes sense to me. That's what we're going to get with a little bit higher resistance between the two filaments of the 6A. I think it's a 688. That's a multifunction tube. So yeah, our filament voltage on both of those is going to be a little bit low. And we're sitting on the 688. We're sitting at about 5.3. That's a little bit low, but that could be another resistor in the circuit. It's good enough. It seems to be working pretty well.